Our goal is to solve the quadratic equation p squared plus 11p minus 12 equals 0, and we want to use the quadratic formula. This is of the form ax squared plus bx plus c equals 0, and anything of this form we call a quadratic equation. Quadratic equation. Not to be confused with the quadratic formula, which is the solution to any quadratic equation. So quadratic equation is the equation. You have to have an x squared, that's the important part, and you need to have it in this form so that it's equal to 0. Once it's in this form and it's equal to 0, the important parts of this are a, b, and c, and here is the quadratic formula, which is the solution to this equation. Here it goes. It goes x equals negative b plus or minus the square root of all this stuff, b squared minus 4ac all over 2a. Okay, memorize this equation if you don't have it memorized already. If you want to memorize it now, pause the video, memorize the thing. You got to memorize it sometime, might as well be now, but you want to memorize this thing. Memorize it. Okay, so that's how you do it. That's the equation. Let's see how we work this thing. So let's look at this example. Here, look, there's nothing in front of this p. Granted, this is p squared instead of x squared. It doesn't really matter what we call the variable. But we have 1 here. If there's nothing there, there's really a hidden 1 here. So there's our a. A is 1. 11 is our b, and negative 12 is the c. Make sure you include the sign with the coefficient. We call these coefficients. All right, here we go. So let's solve this out. We have x equals, okay, negative b, negative 11, plus or minus the square root of, okay, b squared, 11 squared minus 4 times a, which is 1, times c, which is negative 12. Be really careful with your negatives in these quadratic equations, all over 2a, which is 1. Okay, now we just have to simplify this down. All right, negative 11 plus or minus the square root of 11 squared, that's 121. Minus and a minus, minus times minus is a plus, so I'm going to say plus 4 times 12 is 48, all over 2. All right. Negative 11 plus or minus square root of 121 plus 48 is 169 all over 2. Square root of 169 is 13. So we have negative 11 plus or minus 13 over 2. Well, this is actually 2 solutions here for the price of 1. We have the plus case and the minus case. You would never want to leave your solution like this when you have nice round numbers like this. Maybe if we had radicals or complex numbers, but look, right here we have 11 and 13. We can take this further. So let's do the plus case. Let's kind of break it down like this. Let's say, all right, plus, minus, okay. Negative 11 plus 13 over 2. Well, negative 11 plus 13 is 2, so that's 2 over 2 equals 1. There's one of our answers. Okay, and minus 13, so that'll be negative 11 minus 13 over 2. That's minus 24 over, oops, running out of room a little bit. 24 over 2, which is negative 12. Okay, so our answers to this are 1 and negative 12. Now, maybe you're thinking, why in the world would we do this? Because look what else we could have done here. I'm going to start again. P squared plus 11p minus 12. I guess we can just verify that this is a correct solution. Look, we could actually factor this if we were into that kind of thing. P and p plus 12 minus 1, I'm thinking. Set both of those equal to 0. That gives p equals negative 12. P equals 1. Okay, so in that case, why in the world would we even have the quadratic formula? Well, the quadratic formula will work when your trinomial does not factor, right? So it would be overkill, technically, to use it on this example, but a lot of times trinomials don't factor, and the quadratic equation will get to the bottom of it and give you solutions no matter what. So it's oftentimes overkill, but it always works. That's the trade-off.